Perfect. Let me just get back to the beginning of my presentation. Thank you very much for the time to speak now. And great. Okay, so thank you very much. So let me briefly introduce myself. I'm, as I said, Mark Billinghurst. I'm the director of the Empathic Computing Lab, and that's a lab split between the University of Auckland and the University of South Australia. I have a background in collaborative AR and AR and VR interface design, and my research goes back to before 2000. In 2002, I got my PhD from the University of Washington, and one of the first collaborative AR PhDs. But in addition to doing research, I've had a lot of experience in teaching going back 20 years, back to about 2000. We started releasing the first open source tools for AR. And then I've had teaching in a variety of settings in short courses, online courses, running some summer schools and some university courses. So today I want to talk a little bit about that, some of the lessons learned from that, and hopefully it'll be helpful for those of you who are interested in teaching as well. First of all, though, I want to briefly give a brief explanation about what AR is, just to make sure we're all on the same page. And if we look back a few decades, when I was born in 1967, this was the most popular computer in the world. This was the IBM 1401, and half of the computers in the world was this machine. In fact, this machine takes up a whole room of a building, and it cost $10,000 a month to run. So you didn't buy the computers, you rented them. And of course, we all know the story. Since that time, 50 years ago, there's been this evolution of the computers have become invisible. They've gone from the room to desk to lap to our hands. And in fact, from an interface design perspective, one of the goals of interface design is to try and make computers go away so we can improve our interaction with each other or the real world. So this is a picture I stole from Jun Keynote, and it talks about different ways to make computers invisible. So on the top left-hand corner is the traditional user interface that we have, where we've got a screen, and then the screen is separated somehow from the digital space, and there's this gap between the real and digital world. But with augmented reality, the goal is to try and blend the digital content back into the real world, and so really you're experiencing the real world through the digital content. And so, this is an old picture from Star Wars, and this scene from Star Wars, you have Princess Leia appearing as this kind of 3D hologram in the real world. And this really shows the key elements of augmented reality, in that, Ron Azuma talks about how you have these three defining characteristics, where you've got the real and virtual images blended together, and you've got their interactive, and the virtual content appears fixed in space. So, of course, the Star Wars picture I showed was all special effects, but 30 years later, in the 2008 election campaign with Barack Obama, the CNN showed this working for real, and I can show a little video of this here. Huh, that's very strange. It was playing just a second ago.
What's going on in Chicago right now?
Well, there are massive crowds gathered outside here, as you just saw. 65,000 ticketed people.
I think you can hear the audio, but you can't see the video. Is that right? So, sorry about that. I'll skip to the next video. Hopefully it'll play okay. But in this video, you would have seen an augmented reality image of a remote reporter appearing in the real world. So it took 30 years to go from the Star Wars concept to the reality that's playing. But this is more like what we have today. So this is a video from a New Zealand company. And this company is called Quiver Vision. What they do is they provide technology where you can color and place maps, like you see here, and then you use your mobile phone and you hold the phone in front of the placemat, and you can see a little AR character come to life. And the special part about their technology is that the character takes on the colors that you've just colored. So this is very classic augmented reality for mobile phones today. And of course, with mobile phones, almost every mobile phone has the capability to do this. And now you have a huge potential user base of more than 1 billion people that can produce mobile augmented reality experiences. I mean, of course, augmented reality is complementary to other technologies. One of most well known is virtual reality. And virtual reality, again, the idea is to make the interface invisible, because you're immersed inside the virtual content and the computer's generating all of what you see. And so in many ways, it's complementary. For example, with augmented reality or virtual reality, you have to have very realistic graphics, but with augmented reality, even a small amount of graphics is okay. With virtual reality, you want a very wide field of view display, but with augmented reality, a small, narrow, non-immersive display is okay. And with virtual reality, you require very accurate tracking. With augmented reality, with virtual reality, you don't require accurate tracking because the virtual content is replacing your real world. But with augmented reality, it requires very, very accurate tracking. And the final piece of the puzzle is what's called Internet of Things today, where you invisibly embed different technology into your real environment. So the Alexa speakers, for example, is an example of that. So these are 3 different ways to make technology go away. One of the important things about those is that you can arrange those 3 methods in a continuum depending on how much your real experience the computer's generating. So at one side you have Internet of Things, where the computer's not generating very much, and virtual reality is on the other side, and augmented reality exists in the middle. And this is really important because this continuum is oftentimes called the mixed reality continuum. And so when you're teaching about augmented reality, it's important to situate augmented reality and alongside other technologies that are overlapping augmented reality. And so when we teach augmented reality in our classes, we try and provide the context. So that gives you a little bit of background, and then let's talk about teaching AR. So as I said before, with the basic definition of augmented reality is that it involves combining real and virtual images. It's interactive in real time, and it's registered in 3D. And that means that you need different technologies to provide an augmented reality experience. You need some display technology, some input interaction technology, and some viewport tracking technology. And what that also means is that that it involves, it's quite complicated to teach augmented reality because you have to teach both about the fundamentals, so about display, interaction, and tracking, but you also have to teach about how to build augmented reality applications, so how to do prototyping and design and development. And then you also have to teach on an application level around the user experience and user testing and how to build a great quality user experience. And all of these things build on top of each other. So one of the challenges with augmented reality teaching is you have to try and build a teaching program that combines enough of these elements together that the students can benefit from that. And in our programs, we've been teaching, we've found that depending on the class you're teaching, how you mix these different elements together. One of the lucky things, though, is that it's become much, much easier to develop this. So when I first started doing augmented reality in the mid-90s, it was very, very complicated to build your own AR experience. In fact, one of the first AR experiences I developed, it took about 2 months for me to get a virtual cube to appear in the real world. And because of that, around 2000, we released the AR Toolkit open source library. And this was an open source computer vision library that allowed you to simply track from black and white markers and then overlay content onto those markers. So we solved 2 of the big problems of augmented reality, especially from an education perspective. First of all, how to do viewpoint tracking. And secondly, once you're able to track these objects, the objects themselves could support interaction. So the other problem we had trouble was interaction. And we learned an important lesson from this. We released this as an open source tool. And fairly quickly afterwards, we had, I think within the first 5 or 6 years, we had 1 million downloads, which is a very large number for a developer tool. And we also saw people took this software, imported to multiple platforms, and then started using it in their classes. So the very first AR classes I taught were using AR Toolkit. Because students didn't need to know the basics of computer vision, they could use this library to be able to start building AR experiences. And it's really great to see that the open augmented reality book that's being worked on now is that it's continuing that tradition about building augmented reality open source tools, which is very valuable for the education community. And of course, luckily, since that time, tools have developed further. So one of the most important tools now is Unity, and then also the AR engine. And the great thing about development tools like this is that you can get a variety of supporting plugins, such as the Vuforia library, which allows you to plug in and build augmented reality experiences very, very easily. So now in the course of just an hour or 2, you can build your first augmented reality experience, unlike a decade before where it took you days or weeks to build an augmented reality experience. And this is very important from an education perspective because when you're teaching people, you don't want to teach them, they don't want to require some of your students to learn very low-level programming or computer vision to do augmented reality. They want to start building experiences and focusing on the application level. One of the most important things, though, that's happened in the last couple of years has been the development of a number of prototyping techniques, tools that make it very easy to prototype core applications. And this really answers the question, how can we develop augmented reality experience was little or no coding. And when I first started teaching augmented reality, you really needed quite a high level of technical skill. So the only people that we were teaching were computer science students or engineering students that had a very high level of skill. And that was really unfortunate because it meant this whole community of artists and designers and end users was missing out because they couldn't understand or get to grips with technology. But now we've got a lot of prototyping tools that we can use that would allow us to prototype these experiences with little or no coding. And there's a variety of low fidelity or high fidelity. So when we're teaching augmented reality in our classes, we show the students these different skills, and we really emphasize that if they want to build applications, the application, most important thing is to talk about the user experience. And these tools allow you to build user experiences very quickly, ranging from sketching little ideas to making some video, all the way to tools like Wikitude or Tavori, which allow you to build AR with almost no programming. So, for example, on the left here is the Lens Studio, and this year we were teaching an AR class to some design students, first-year design students with very little technical skill. But with Lens Studio, with just in half an hour, they could start building their own little augmented reality face tracking applications. And then on the right is Adobe Aero, which allows you to prototype augmented reality on the device itself. So just to give you a couple of examples, one of the applications I've used in the past, which is really good, is Craft AR, which is a web-based tool for marker-based augmented reality. So you can basically take a magazine page, or you can take a drawing, and you can drag and drop content onto this and turn into an augmented reality experience right away with no programming. And so this is really good for design classes if you really want to focus on developing the content or the user experience. So let me show you a little video of this. So what this video will show is how to add 3D models to Craft AR. And you have this web interface here. You just click on the add new item, and then you can create a new tool, and you build an AR. You upload the image you want to track, and then now you've got this interface with that image. And then on top of that image, you can add 3D content. And when people see this picture or the poster, then that content will automatically appear on their mobile device. So here's some pair of shoes that they've loaded. They're just changing the scale. So this is very, very easy to use for non-programmers. And because it's a web-based, you can deliver across multiple devices. So tools like this make it very, very easy to start teaching augmented reality. Another tool is the Adobe Aero. So let me show you a quick video of this. And Adobe Aero allows you to create AR right on the device itself. So with Craft AR, for example, you typically do it on your desktop computer, then you'll publish it to a web or mobile browser, and you watch it on your phone. But with this, with Adobe Aero, you can edit on your tablet, and you can view the AR content right while you're editing. So let me show you a video of this working.
I love painting with my entire body. That's why I love making murals. I just really like the idea of art expanding into three-dimensional space. AR makes that possible for me to create motion on a two-dimensional plane. It's really cool that I can export my Photoshop files into Aero and manipulate those layers in 3D space. I can walk through them. I can see the distance between those layers. It becomes a very real, almost tangible experience. Augmented reality is meant to be shared, and Adobe Aero makes it really easy.
So I'll stop there, but that gives you an example. And in my classes, we always talk about the importance of trying to sketch ideas out and then produce an outcome at the end. So I just want to give you a simple example of how that would work in a class. So in this case, for example, the students wanted to build an AR hockey game. And the idea was to play air hockey in the real world and to be able to have virtual content bouncing around the walls of a room, and then having the players hit that with their real hands and being able to play it like air hockey. And technically to build that's very complicated, but to prototype it is relatively easy. So I'll show you some of the steps that was done. And then in the courses that we teach, especially for the design course I talked about before, the idea of that course is to try and produce a prototype that people understand the concept and not necessarily produce a final working AR experience. So in this case, the first step was to produce a small, simple sketch. So the sketch here shows how they had the idea to use the Microsoft Kinect to track people, they project with a projector onto the floor, and then having people being able to hit virtual balls around on the floor and the wall using some sort of ping pong metaphor. Here's a bit more complicated sketch that shows some of the sketched interface elements, the score line and so forth. And then they produced a nicer mock-up that showed how they want to be able to drag the virtual content from one wall to the other, and as it moved around, there was some physics effects happening as well. And to be able to prototype that to see it was fun, they did some paper prototyping, and in this case, they had one person who was acting out the role of the ball. So you see the woman there with a red dot on a stick, and then she would run around the court and move around, and then they had real players that were trying to hit this and act like they were hitting the real object. So even though they didn't build any real working technology, they could still see if that experience was a fun experience. And then finally, they built a little physical mock-up. They used little miniature Lego pieces, and they made a projector to project onto this little cardboard room, and they showed the application working. So let me show you the final video of the system working. So they made a little stop motion video, and then they showed the application running. So I'll stop that running there, but the key thing from this is that the students were able to prototype an augmented reality application without doing any coding at all. And they still, from this project experience, were able to explore different design concepts and get some user feedback and get some understanding how an augmented reality experience might be. And so in our classes, we try and teach students that they don't need to all be amazing programmers. They can do project work like this and still create an AR experience or similar AR experience without doing any programming at all. Of course, there's really great resources that you can develop on. And as we talked about before, the Open Augmented Reality teaching book's a really valuable resource. There's also a couple of really good books from Addison Wesley, the book on augmented reality by Dieter Smolstig, and practical augmented reality as well. The Dieter Smolstig book's especially good because on the website, the augmentedrealitybook.org, they have a whole curriculum material for teaching, and so they have all the slides there and everything, so you can teach them that. And the book itself does a really great job of covering those foundations, and that's one of the most important things that you can teach students is to understand the foundational technology, even if they don't do low-level computer vision programming and so forth. So what I want to talk about now for a few minutes is different types of teaching, some of the lessons that I've learned from that. And so, for the last, I guess since 2002, I've been teaching undergraduate courses on augmented and virtual reality. And these courses are typically about 10 to 12 weeks long, and they cover, the introduction to what augmented reality is, the fundamentals like I talked about, some prototyping tools like I showed. Oftentimes they'll have tutorials that run alongside them so people can learn in the tutorials. And then if there's enough time, we'll do specific topics on different things like mobile augmented reality or collaboration or user evaluation. And then we typically close with a lecture or so about research direction so people can understand what the importance of topics of research are, and that might lead on to further study. And the assessment for these courses typically involves short assignments or programming, and then often a group project. For example, in the design course we taught, we had students working in groups of 5 to build AR experiences. So as an example of that, this is the course that I've been teaching at the University of South Australia. In fact, we just finished it just 2 weeks ago. And this is a 13-week course, typically have between 15 and 25 final year computer science students. And the course is an AR and a VR course. Oh, I made a mistake in that. It should be 7 weeks of virtual reality and 5 weeks of augmented reality because they quite closely overlap. So we basically try and teach the fundamentals and we combine some special topics. It's 2 hours a week of lectures, and we have a tutorial, and the tutorial really focuses on Unity. Because these are computer science students, we go into a lot of depth about how to program with Unity to program AR and VR experiences. And the assessment is really programming, and then also they produce some reviews of papers. And again, because they're computer science students, we can go in quite depth, and they can build some quite complicated programs. So this is typical of what you might have in an undergraduate course. Of course, the content varies depending on the skill level. So, for example, in the design course, it was also 13 weeks. But in that course, we emphasized more on the interaction design of augmented reality. And we had students working in groups, and that was really important because we could mix different skill sets together. So we made sure that each group had at least one or two programmers in it, but they might also have a content developer or a storyteller or an audio artist. And so because they had that programming support, they were able to build things. But because they had the content support, they could build some quite nice experiences. Then, in addition to that, I've done some intensive summer schools, and these typically last between 3 and 5 days. And again, they involve some of the fundamentals. They give people an opportunity to have technology hands-on. We oftentimes bring guest lecturers in, but more than half of the time of their summer school is taken up with development and project work. So typically, you'll have lectures in the mornings and then project work in the afternoons, sometimes even into the evenings if students want to work that long. And of course, in this case, there's no real assessment, but the students are encouraged to do a project presentation. So an example of that is this summer school we taught last year, Imagine Summer School. We had a 5-day summer school in New Zealand. We had an open call for students, and we attracted 40 students from 85 applicants from both industry and academics. And then we had 15 hours of lectures, mostly in the first few days. So the first day was 6 hours, second day 4 hours, and then we went down from there. And then about 16 or more hours of coding. We had 16 hours of formal coding, but the students oftentimes would work into the evenings, so it was later. And the course was really emphasizing fundamentals of what AR is, and then the user experience. And then we had, because it was focused on Magic Leap, we had a lot of help or teaching a lot of how to build for the Magic Leap AI headset. And people worked in projects again with an emphasis on trying to build a demonstration for the open houses at the end of the week. Another type of course is short courses, and so these typically 2 to 3 hours long, and really often tightly focused on one particular aspect of AR, with a lot of links to future resources. So if people really can't explore in depth, but you can show where to go for more depth. So an example of this is a course that I taught in 2013 with the High conference. And at this conference, it was a 3-hour course. We had 60 attendees from the Kai conference. And because they were all at the Kai conference, they were really emphasizing human-computer interaction or design. And so this whole course was about how to design AR experiences. And so we went through the design cycles and prototyping tools, evaluation techniques, research terms. And then most importantly, we had, in the middle of the course, we had a break where people would try hands-on with AR technology. So mobile phones and tablets and head-mounted displays. And then the final type of course, which of course is very popular now, is online learning. I haven't run a lot of online courses, although most of the teaching material I produce, I put online in through SlideShare. But with online courses, the emphasis typically is on short videos and really focusing on hands-on, how to follow along the instructor to build things with links on to background material. Focus mostly on tools, not theory. And there's, of course, again, no assessment, but typically some sort of forum participation. So a good example of that is Udemy. If you go to Udemy right now, you'll find about 45 courses that teach augmented reality, and they range in cost from $10 to $20 US, and they take between 1 and 20 hours to complete the courses. An example of that is this one, building 15 Vuforia applications with augmented reality, and this one takes about 20 hours. You'll see that over 14,000 or nearly 14,000 people have taken this course, and it's got a very good ratings. 2,500 people have rated it at an average of 4.5. But with this type of course, the emphasis is really on hands-on doing. So you can see here's the lectures where they basically walk you through installing Unity. There's 186 lectures, so a large number of lectures, but really most lectures are 5 minutes long or shorter, and they take you through the basics of Unity, then step by step through building various apps. So I want to finish today by talking about some of the lessons that I've learned through this teaching, and I should mention that all the slides I've talked to you today, I'm happy to share with you. I'll share my email address shortly, and if any of you want to talk more, I'm happy to talk more as well. So a few lessons I learned. First of all, it's really important to know your students. It's obviously very different teaching a course in computer science and teaching a course in design school. So you really have to carefully know the skill level of the students, what their expectations are. Regardless of the course that I've been teaching, I think it's really important to develop a strong fundamental understanding. So as much as possible in those courses, I talk through the display, interaction, and tracking fundamentals, because that's underlies everything in AR, and people really can't build good AR experiences unless they have an understanding of those fundamentals. So, in most cases, in my classes, we don't teach students how to do low-level computer vision, but they need to understand what some of the possibilities are or limitations are so they can use available tools or libraries to build AR experiences. And similarly, they need to be able to understand what's technically possible with different display technology and so forth. Then the other important element is to teach from a variety of sources. And today, we're very, very lucky that we've got a huge range of material available to teach augmented reality, from some of the books I've shown you, which if some students are really like being able to use a traditional textbook, to some fantastic videos, to online material like I showed you with Udemy, and to material that other people are developing, including the open source augmented reality, what we talked about before. So in many cases, what I do is I will teach the fundamentals and then point students to resources, and then they'll be able to teach themselves from some of those resources. For example, there's a huge amount of resources on YouTube showing people how to build augmented reality experiences using Unity. The other important thing is to provide hands-on experience. So, through YouTube and other mechanisms, you can see videos of fantastic AR experiences. But until people put head-mount displays on or try and track their bodies with some tracking technology, they really can't understand the pros and cons or limitations of just technology. So when I've been teaching classes in the past, typically I'll use some of that class time to bring technology from my laboratory and then people can try it out, or to bring people into the laboratory to try different things as well. And even when I've been teaching short courses at Kai or other places, I've brought a lot of technology to the courses so people can put the displays on and try it. And again, the good thing from the technology teaching perspective is that there are many apps available now. So, in my classes, I can easily ask students to go away and find 4 or 5 mobile AR apps and try it for themselves. Or I can load up applications onto the HoloLens and have students try themselves. The fifth thing is really engaging with the community practice, and I think that's really important with the open source AR book, is that we've now got a community of practice that can help support teaching. There are a number of different researchers that can you can engage with to find out the latest in AR research. There's a lot of people from industry that will give short courses or lectures, and in my courses I oftentimes bring guest lecturers in. And then most importantly, there are other teachers you can draw upon. If you go to resources like SlideShare or other online resources, you can find a fantastic amount of resources there. And then finally, one of the things that you can do is you can provide back to the community. So when we started doing research in the HIT lab when I was doing my PhD in augmented reality, we pretty soon discovered, myself and colleagues there, that there were really no tools available for teaching people about how to build AR experiences. And so we built our own tools and we shared them with the community, and that was really a great way to grow the community itself. And so if you are developing teaching material, whether it's an open source tool, a textbook, or some step-by-step tutorials or some low-level code, please share it back with the community so everybody can benefit as well. So that's pretty much all I want to talk about today. I'm not sure if there's time for questions. I know that there'll be definitely a panel after this, so I'm happy to participate in the panel. But if you'd like any feedback from me, please reach out and contact me through the email address here or my Twitter handle or through our website. And I'd love to hear from you about what resources you're using in your own teaching and how we can build much better content for teaching AR. So thank you very much for the time. And if there's time, Mikhail, I'm happy to answer a few questions now, or we can go straight into the panel discussion.